Okay, so how's everybody doing today? Hey, this is going to be Vodcast number 2 for the blood, and this is going to be a little bit longer because there's just not an easy way to break this up. Now, don't forget, today I'm going to have embedded in this PowerPoint some clues for you to go and answer a question at the end of the Vodcast. You're going to need to send it to me on Edmodo tonight to get your extra credit for your upcoming blood test. Okay. Formation of blood cells. Most blood cells need to be continually replaced. That's because they die within hours or a few days or some of them a few weeks. The process of blood cell formation is called hematopoiesis. It's also known as hemopoiesis, but we're going to use the term hematopoiesis. And it occurs in the embryo as before you are born. It occurs in the yolk sac, the liver, the spleen, the thymus, the lymph nodes, and the red bone marrow. So it's quite a few places that it occurs. Now, once you're born, and as you age up a little bit and you become an adult, it only occurs in the red marrow of flat bones or the ends of the long bones. And we've talked about that before. So, first part of the extra credit question, by the way, is the number 4. Okay, so in hematopoiesis, we start off with a pluripotent stem cell. Now, another name for that is hemocytoblast. And we know the term cytoblast because that's build. Well, in this particular case, it's all about making other white cells. So here we go. First kind of cell that we're going to make all the way over to the left is a proerythroblast. And here, the nucleus gets ejected, and that process, after the nucleus is ejected, we call that a reticulocyte, and that becomes a red blood cell. The second kind of cell that we develop is the megakaryoblast, and these build megakaryocytes, which eventually break into pieces, and we call those platelets. Another cell that the pluripotent stem cell can make is the monocyte, which has a mature form we know as a macrophage. These are the cells that kind of, through the process of phagocytosis, eliminate invading bodies. The same process from the same cell, we wind up with neutrophils. Remember, all of the phils are the granulocytes. These all have granular cytoplasm, and you see that when you stain the cells. Stem cells also make eosinophils and basophils, and they just come from the same kind of myoblast, eosinophilic myoblast and basophilic myoblast. Now, the lymphoid stem cells come from two different places, again, still from that pluripotent stem cell, so that one stem cell, otherwise known as the hematocytoblast, also creates the B cells, the pre-B cells, and the prothymocyte. Now, the pre-B cells will make the B lymphoblast, which will make the beta lymphocyte, which will make a plasma cell. And the prothymocyte will make the T lymphoblast, which are the T lymphocytes that we've talked about. That's hematopoiesis. The exact methodology you don't have to know, you just have to know where they come from. The red blood cells, otherwise known as erythrocytes, these are the ones that contain oxygen-carrying protein hemoglobin, and that gives blood its red color. It's about a third of the cell's weight. And these are bioconcave discs, and what's important to remember is that the increased surface area to volume ratio provides a way to carry a lot more oxygen. It's got a very flexible shape for narrow passages through capillaries, and it has no nucleus and no other organelles. It can't do cell division or can't do mitochondrial ATP formation, nothing. It just carries oxygen and carbon dioxide. Here's a picture of hemoglobin, a couple of different pictures. One all deals with the size and the shape, so that's all the way on the left. In the middle, you see the actual hemoglobin molecule, which is a quaternary protein. And the key to remember about this protein is that it has an iron base, an iron core. And iron is what gives it its ability to carry oxygen. The life cycle of a red blood cell, they only live about 120 days. They wear out from bending and trying to fit through the capillaries, and there's no repair possible because there's no organelles to repair it. So these worn-out cells are removed by these macrophages that are in the spleen and the liver. These are fixed macrophages. They're large cells that do phagocytosis, and they're found in the spleen and the liver. And all the breakdown products are just recycled. There's a feedback loop that we'll discuss in class tomorrow. I just want you to take a look at this. The challenge is tissue hypoxia, and this is where cells don't get enough oxygen. So there's a couple different possibilities. It could be at a high altitude and air has less oxygen per liter. You could be anemic, and that could be that the red blood cell production is below the destruction of red blood cells, or you have an iron deficiency, or you could have circulatory problems. Well, the kidney is what responds to hypoxia. It releases erythropoietin, which is the hormone that is going to speed up the development of pro-erythroblasts and create the reticulocytes. And on the right here, you see the process, the feedback process. Now, the white blood cell anatomy and types, right? All the white blood cells have a nucleus, but they don't have any hemoglobin. They can be either granular or agranular, based on the presence of those cytoplasmic granules. And again, the granulocytes are the phils, neutrophil, eosinophil, and basophil. And the agranulocytes are the ones that are either the monocytes or the lymphocytes. So you should need to read about each one of the different types of cells. The neutrophils, these are, we saw the pictures of them in class yesterday or earlier today, and they're the majority of your circulating white blood cells. The eosinophils are kind of large size. They are 2 to 4% of the circulating white blood cells. Oh yes, and this is the second part of the extra credit question, is the number 3. Basophils are large. They stain dark. Purple, and they are less than 1% of the circulating white blood cells. Lymphocytes are dark. They're oval to round nucleus. They're small cells, some small, some large. They increase in number during viral infections, and they're about 20 to 25% of all the white blood cells circulating in your bloodstream. Monocytes are agranulocytes, right? They have no granules in the cytoplasm. The nucleus is kind of either kidney or horseshoe shaped. We saw that again in class, the largest white blood cell in the circulating system. And it doesn't remain in the blood too long. What it does is it migrates out of the capillaries, out of the bloodstream, and goes out into the outer tissues. And they primarily differentiate into macrophages. And they identify with specific tissues. And these protect the tissues from invaders. They're called alveolar macrophages, and if they're found in the lungs, they're called Kupffer cells in the liver. And then there's some wandering monocytes that will move to any site of infection. And they're about 3 to 8% of circulating white blood cells. White blood cells are far less numerous than red blood cells. We talked about that. Leukocytosis would be a high white blood cell count. And this could be as a result of microbes, invaders in the body, strenuous exercise, anesthesia, surgery, any of those kind of things that would cause a problem with blood cell count, where the leukocytes have to come out and act as defenders of the body. Leukopenia is low white blood cell count, and this could be due to radiation, shock, or chemotherapy. And again, this is primarily cancer treatment. About 2% of the white blood cell population is circulating in the blood at any given time. The rest is going to be found in lymphatic fluid, skin, lungs, lymph nodes, and the spleen. Here's a quick picture of how white blood cells emigrate out of capillaries or blood vessels. And you can read this, and we can go over this tomorrow. Neutrophil functions. These are the fastest response of all white blood cells to bacterial infections. The quickest response. They take direct action against bacteria. They release lysozymes, which destroy or digest bacteria. They release proteins called defensins that act like antibiotics, and they poke holes in bacterial cell walls to destroy them. And they also release strong oxidants, bleach-like strong chemical substances that destroy bacteria. Well, monocytes take a lot longer to get to the site of the infection, but they arrive in larger numbers. And these become those wandering macrophages once they leave the capillaries. And these destroy microbes and clean up dead tissue following an infection. Basophils are involved in inflammatory and allergy reactions. They leave the capillaries and enter connective tissue as mast cells. And if you go back to our study of mast cells in tissues, chapter 4, you'll remember what mast cells look like and where they are. And basophils release heparin, histamine, and serotonin. And these heighten the inflammatory response for allergic reactions. They reduce your sensitivity. Eosinophils, they leave the capillaries, they enter the tissue fluid, the interstitial fluids. They release histaminase, right? This is an enzyme that slows down inflammation that's caused by the basophils. So you got the basophils that are releasing their substances to reduce your reaction to allergens, and then you've got the eosinophils that are slowing down the inflammation caused by the basophils. Eosinophils also attack parasitic worms. They phagocytize any antibody and antigen complexes, and those are, as we discussed today, those are the antibodies that protect you from coming down with the disease a second time. Yes, the last part of that extra credit question. You can read this and solve it, and then follow the instructions. Okay, lymphocyte functions. We got beta cells, which destroy bacteria and their toxins. They turn into plasma cells, which produce antibodies. T cells attack viruses directly. They attack fungi. They attack transplanted organs. They attack cancer cells and some bacteria. And these are the ones that sometimes attack your own cells, such as the ones we saw in the pancreas that cause type 1 diabetes. The third kind of lymphocyte is the natural killer cells, and these attack many different microbes and some tumor cells. They destroy foreign invaders by direct attack, and sometimes these are also involved in the destruction of beta cells in your pancreas. That's the end of the Vodcast. I'll see you in class tomorrow. Don't forget to send me the answer to the extra credit question on Edmodo tonight.